Okay, this is a review for the Honors Higher Algebra Semester 1 quarterfinal, so actually quarter 1 final, the quarterfinal. And it's going to happen on Thursday, and today's Monday, so we have basically 3 days to review for this big test. We've got a lot of topics to cover, because we've covered a lot since the beginning of the school year. Won't get anywhere near through all of it today, but I'll get through some of it. And this folder, the pale green one that says quarter 1 final review, that's the one you want right there. So everybody jump into that one. And I'll tell you which of these things I want you to do for homework. I don't want to tell you right now because I'm afraid some of you won't help do the practice problems with me right now that are going to be really important to understanding it. So I want to wait to tell you a little later which of these things I want you to actually do. Oh, one more thought on the retakes. As I mentioned, this big test upcoming can count as a retake of previous tests. You have to have done corrections to qualify for the retake. I've already told you that. If you haven't, if you're like, you know, that one test, I'd like to go back and do corrections, you still can, but you got to get those done by Wednesday during MAST would be a logical last time. I suppose I could let you do it Thursday morning if you're really busy. You want to wait till Thursday morning and do it. You've got to get corrections done before you take that test, though. You can't like take the test and then realize, dang, I did really well. I wish I would have done corrections on my test so I could qualify for a retake. If you want to do a retake, do the corrections now or by Thursday morning. Okay, so what I'm doing for today, before I tell you which problems I want you to do for practice, is just a review on a blank notability doc here. And I'm going to just kind of go through since the beginning of the year, and I won't get through all the topics, but I'll do a bunch of practice problems with you, have you try them with me. So the first topic we got into had to do with functions like f of x. And let's say f of x is equal to 3x plus 1. And then we quickly got into like, what if we have another function like g of x? And we said that was like 1 over x. Well, one of the easy kind was just like, what's f of 8? Don't say it. Stick it in, figure it out, write it down, and turn and show the person to your left or right. I'll pair you right now with who I want you to work with and see if you get the same answer as they do. Okay, it took longer than it needed to because I was getting attendance done. But here we go. 8 goes into the f function, which is right there. And remember, that's like an empty parenthesis waiting for something to drop in. You drop in an 8. 8 times 3 is 24 plus 1, 25. I know you almost all would have gotten that, but did you know that represents a point on the function? If I was graphing it, what point do you know for sure is on the graph? 8, 25. That makes sense to you? That's telling you a point. If this is the x of it, and this is the y of it. What's y also known as? F of x. Y also known as f of x. Okay. So, what is f of p? I know you don't know what p is, but you can still tell me what f of p is. I just told you effectively that x is p. So, what's f of p? Turn and compare with the kid next to you that I paired you with. See if you get the same thing as them. Okay, sensing a lot of confusion on this one, but really it's just like this. You get, last time I said f of 8, and you went and stuck the 8 into the function. Boop, like that, right? So when I say f of p, all you have to do is take the p and stick it in the function. 3p plus 1. The answer for that was 3p plus 1. Raise your hand if you think you understand that. Okay, good. Then, what's f of p plus 3? Well, did you just take the p plus 3 and stick it into the x spot right there? So you'd have 3p plus 3 plus 1. It's the same exact function with a p plus 3 stuck in. That's it. Now, you do have to multiply it all the way out. I don't know if you noticed that, but that's what you're supposed to do. 3p plus 9 plus 1, 3p plus 10. Final answer. You following that? Okay, good. Next, let's try f of g of 3. F of g of 3. By now, I've taught you how to start difficult problems that have a bunch of parentheses in them. If you start it the right way, this really isn't too tough. So where do you start? Inside. What is g of 3? How do you know that? Because you stick a 3 right there. Stick a 3 into the g function and you get 1/3. So this whole thing becomes 1/3. And then it's f of 1/3. Mr. S, take it from there. Yeah, it's kind of like this. This is the original f function, except I dropped in an empty parenthesis where the x was. And then I put in a 1/3 there. Final answer? Yep. That part comes out to 1 plus 1 is 2. How many of you had that before I said it? Okay, good. Now, let's do that same idea except with pictures. Actually, let's do one more like this, because I could do one more like advanced thing with it. What if I said 2 f of 3 minus 1 all over negative g of 2? Tough problem. Where do you start? Parentheses. You see any parentheses up there? I do. I see 2 different places with this parentheses, so I do both of those parts first. Figure out these 2 spots first. I'll pause for a second while I give that a shot, and then compare it with the kid next to you. Okay, let's get back to it. F of 3, man, I stuck a 3 into the f function. Okay, f of 3, and I stuck a 3 into this function right here, which makes 3 times 3 is 9 plus 1 is 10. That made it 10. You guys get the same thing there? Okay, so that 2 times 10, which is 20, minus 1 is 19 on the top. Over, what's on the bottom? Well, I stick in a 2 into this function right here. So I stick a 2 in right here. And I have 1 over 2, which is 1/2. So this part right here becomes 1/2. Don't forget the negative. Negative 1/2. Negative 1/2. That's weird. A fraction over a fraction. I have told you how to handle that, though. That's in the top 20. You remember a fraction over a fraction? 19 over 1 divided by negative 1 over 2 is exactly like multiplying by flipping it. You change this to times, and you flip that negative 1/2 to negative, I don't care where the negative ends up, 2 over 1. And it's got to be negative. Final answer, 38. Negative 38. Raise your hand if you had that one right. Excellent. Okay. Now we've covered quite a few topics, but certainly not all of them. Now we're going to turn for a while to some graphs. I'm going to give you a graph, and we give you some points on that graph. Let's say it starts here at 0, 1. And then another point on my graph is here at 3, 4. And another point is, let's say, here at 7, 6. Then we'll pick one more point at 8, 12. Way up there. All right, first question is simple. What happens, here I'm going to run a line through all of these. If I asked you what f of 3 was. I hope that's an easy peasy one for you. That's the easiest kind. When I said f of 3, was I telling you an x or a y? I was telling you x was 3, right? So if I say x is 3, you have to then say, well, if you stick 3 into the function, you get what? 4. Good. This point right here. In fact, I'm going to write it right underneath. F of 3 is 4. Do you get that? If the answer for this is 4, that's what you're saying. F of 3 is 4. And you just named a point. 3, 4. Do you get that if I say f of 7 is negative 2, I just named a point on the graph? What point did I just name? 7, negative 2. Good. All right. Just making sure you get that correlation. Okay, good. So the answer for this was just 4. F of 3 is 4. Okay, so what's f of 7? Not super complicated. It's just 6, right? Okay, good. All right, now we got to step up the difficulty level. What if I say f of x is 12? What is 8? X is 8. So do you get, I could write right underneath this, f of 8 is 12. And by doing that, I'm naming this point right here. I know it's on the graph. And then this f is the same as this f. They're the same. X must be 8 then. And the 12 is a 12. And they all match up right over the top of each other. That method where I write the point underneath it is really important. Let me prove it. Because this is the kind that blows people's minds. F of 3x plus 1 is equal to 6. Minds explode. But really, if you can write something underneath it that's just a simple little point, then you're almost done. You'll just have to solve a little equation. So on this problem, did I give you x? No. What did I give you? Y. Yes, I told you y was what? 6. So I go through these and I find where y is 6. That's the only one where y is 6, right there. Therefore, what did I just figure out? 0.7, 6. How do you write that? F of 7 equals 6. Now, do you get, when I write it that way, that these are identical? And these are identical, and these are identical, all known as equals. So therefore, do you get that 3x plus 1 must be equal to 7? All right. So therefore, what's x got to be? Well, we subtract 1 from both sides, and I have 3x equals 6, and then I just have to divide by 3. X equals 2. Raise your hand if you had to. Okay, good. Let's do another one like that. These are tough. F of negative 2x minus 4 is equal to 4. I didn't tell you x, I told you y. I want you to write your answer down, and then I want you to compare it to the person who's sitting next to you that I paired you with for today. Write it. See, that's dark. It tells me something. Okay, so you should have said, okay, Mr. Server, you didn't tell me x, but you told me y. Y is 4, and therefore I know this point is important, because that's the one where y is 4. And then you write it right underneath. F of 3 is 4. And then if this is the same, and this is the same, and this is the same, then that's got to be the same. Negative 2x minus 4 equals 3. Raise your hand if you wrote that. All right, that's what you should have written. And then you actually solve it. So you add 4 to both, and you'd get 7, and then you divide by negative 2, and you get x equals 7 over negative 2, or it doesn't matter where the negative is, negative 7 halves. Raise your hand if you had that answer. Okay, good. That's some of the toughest kind. Now, that doesn't cover everything by any stretch of the imagination, but we've covered a bunch of things. All right, let's move to a new topic. So do you remember increasing at an increasing, and increasing at a constant, and constant, and increasing at a decreasing? Do you remember those kinds of things? Okay. So if I were to say that this was me putting gas in my tank. You know, you're standing there at the gas station, you squeeze the little nozzle on the handle where you're filling up your gas tank. If you squeeze it really hard, it goes in fast. If you just squeeze it really lightly, then it goes in kind of slowly. Okay, so you could actually replicate this by standing at the gas pump and squeezing the handle. Okay? At what point, and this may be a trick question, A, B, C, or D, was gas going in the fastest? At what point was gas going in the fastest? What do you think? Tell me what you mean by you chose B. Why? Okay, you're not thinking about it quite right, but I really appreciate you giving it a shot. B is not the correct answer. What do you think? He says it's A because it's increasing at an increasing rate. You're right on all of those things. But I would contend that within the A range, you could give me an even more specific answer. The second half of the A range. Why? Why is that better than the first half of the A range? How can you tell it's going slower at the beginning? The slope, exactly. It's all about the slope. And steeper is faster. If you didn't know that before, write it down. I said it before when we learned this stuff. Steeper is faster. Do you remember on the test, a lot of people there was a question like this on the test before, and a lot of people got confused about like which part was like going faster than the other part. The faster is the steeper. I would say that right in this little section right here, the slope of that little equation right at that spot is probably about the steepest that there is at the end of A. Where's the only other place that could get close? Yes, sir? Where in D? Beginning or end? Beginning of D is also pretty steep. I'd say that's about the slope of that one. Did you get how both of those are pretty steep, but one's steeper than the other? So I would say the end of the A section is probably the steepest, and therefore gas was going in the fastest. Steeper is faster. Okay, so then let's ask it the other way. At what point on this graph was gas going in the slowest? Yes? Explain why you say C. It's barely going up at all. From here to here, the amount of gas in the tank. In fact, you could even argue it's flat. If it was flat, okay, going down means I must have a hole in my gas tank, and that's probably not good. So assume for a moment that that was meant to be flat. If it was flat, what does that say about me and putting in gas in the tank? I stopped. I stopped for a while to eat a Hot Pocket or whatever I bought at SA. Okay, cookies are good option. All right, so stopped. I can't beat stopped as being slower than stopped, right? Unless you would argue that there is a hole in the gas tank and it actually is draining out, which is kind of like, yeah, negative going up. All right, anyway, I'd like you to draw me one like this, and I'm going to say it verbally, And you see if you can make a thing like this. It's going to start not like this one where I said increasing at an increasing. I want you to start with a section A where it's increasing at a decreasing. Make me a little picture. Part A of the graph is increasing at a decreasing. The next little section is part B, and that's going to be constant. The next part is decreasing at an increasing. The amount of gas in the tank was decreasing at an increasing rate. And last section of this graph, increasing at an increasing rate. Now let's see if your picture generally matches up with mine. Did you start with this increasing at a decreasing? That's how you're supposed to start. Okay. Why is it decreasing? Because it starts steep and it ends up not as steep, and so it's decreasing. The steepness is how fast it's going in. That's why it was decreasing. That's decreasing. Here's constant. It's part B. Part C was decreasing at a, what did I say? Increasing. Decreasing at an increasing would mean like this. That's decreasing at an increasing. Why is it increasing? Because it starts out kind of slow, ends up kind of fast or steep. If you're having trouble taking notes on this, you can always at least draw my graph and say what I said it was. That part C there was decreasing at an increasing. And then last, it changed over from that to increasing at an increasing. Faster and faster. Part D. Could you shut that door for us, please? Thank you. I know we're out of here in about 2 minutes. So, here's what, yeah, you got to go. I understand. Here's what you do for your homework for tonight. I've never assigned this as homework before, but I'm asking you to do a Schoology quiz. See if I can find it here. Oh, it's over here. You're going to do, listen to this before you leave, you're going to do the first Schoology quiz that you come to in this folder called Quarter 1 Final Review. This top one right here is called Test 1 Function Review Quiz. Okay, that Schoology quiz is to be done. I don't expect you to be perfect, but anything you get wrong, you should look back over it and try to figure out, what did I do wrong? That's your homework for tonight. Yep. Have a good day.